me share my screen once again, and oops, here's one more. It's never too late. So, hi everyone. Thanks for being here with us on another Tesseract Academy event. I'm Stelios, and I will be your host for today. I'm afraid I can't turn my camera on because my camera unexpectedly stopped working today, but Shashank, who is our speaker, our main guest for today, his camera is working, so that's great. I can assure you that I don't get much better in live than you see on this photo. So let's get started. So today Shashank will talk to us about, he will introduce to us the concept of Internet of Things and some basic concepts and ideas around Internet of Things with a focus on the decision maker, right? And the non-technical executive. By that, we mean any entrepreneur, any manager, anyone who is in a position to make decisions within a company who is thinking to work with IoT, but they're not planning to develop the technical skill set themselves. So they're thinking about maybe setting up a team to work with IoT, or maybe adopting an IoT-friendly strategy within the organization. So what's the optimal way to make these decisions? What's the optimal way to adopt IoT within an organization? Where are the biggest opportunities in this regard? So this is what we're going to talk about. And this is something that aligns very closely with the interests and the goals of the Tesseract Academy. The Tesseract Academy is a company whose focus is on helping decision makers, whether we're talking about entrepreneurs of small startups or big organizations, to understand and implement technologies like data science, AI, and blockchain. We help many companies grow through data science, whether this means that whether this refers to a startup that increased its valuation through the correct data strategy, through the correct implementation of a data strategy, or whether this refers to a big organization that is looking to create a new data science function. And we specialize in many things, data strategy being one, another one being running these types of events where we educate the public and decision makers on topics like Internet of Things. Here are some of the entrepreneurs that we've worked with in the past, and here are some of the organizations that we have worked with, from startups to academic institutions to very big organizations like Vodafone and the US Navy. So a few words about who I am. As you can see, my name is Stelianos. You can call me Stelios. I've been in this area, the area of data science and AI, for a very long time. And I'm involved in various things, amongst others, heading the Tesseract Academy. I'm an advisor, a data science advisor at London Business School, and also a research fellow at UCL's Blockchain Center. And I've spent so much time, so many years working in the area of data science and AI for decision makers that I even wrote a book. If you want to get access to the book, please make sure to go on our page and register to our newsletter, and you're going to receive a full free copy. If you want the book in paperback, then you can just buy it from Amazon. Links to follow in the chat. So the Tesseract Academy runs various programs, and the goal is always to help your business make the most out of data. And again, you might be a manager in a big organization, an SME, you might have lots of data that you want to make the most out of. This is something that we can help you with. But even if you're a sole entrepreneur and you have no background in data science, you're just starting out working on your idea, then we can still help you out, because setting a data strategy from day zero can only help your company's valuation increase by making the right moves and presenting this under the right light in front of investors. So today, we're very lucky to have a very experienced guest speaker, Shashank Yadav, who is a leading instructor for IoT at Coding Dojo and has trained more than 3,500 students and professionals all over the world. He has also developed more than 42 product-based courses for IoT technology, and Shashank will cover the basics of IoT, again, taking the perspective of someone who is an executive, a decision maker, and doesn't want to get bogged down into technical details. So today's session will give you a small taster of what is a full workshop that the Tesseract Academy is running in partnership with Shashank, which is going to take place over the next few months, and you can buy a ticket here. A note around the workshop: our workshops are always done in very small groups in order to preserve the quality and the interactivity of the workshops. It's going to be online, and once you go on Eventbrite, you can ignore the date and the time, because the actual date and time are always determined between the participants and the instructor, right? So if you say, hey, I can't make it on that day or time, don't worry, this is something to be determined by the instructor. And also, there's going to be, for those of you who want to attend the workshop, if you miss a session, there's also going to be a recording. We have a Slack community to answer questions, etc. And the goal of the full workshop is essentially not only to cover all those topics, but also help you design a strategy and implement a strategy around IoT, right? We'll go into much more depth in those topics, and also into potential synergies of IoT with data science and blockchain. So without further ado, I think you heard enough from me. Now I'm going to stop sharing, and I'll ask Shashank to share his screen. Shashank, the stage is yours.
Okay, thank you, Dr. Stalinos. Okay, hello everyone. So, as Dr. Stalinos mentioned, that we are going to cover the basic of IoT today, right? So, this is basically going to give you an overview about the technology, what are the key concepts and some of the current market trends. So that will give you an idea if you are a decision maker. And in the presentation part, if you have any questions in between while I'm explaining any topic, so you can just drop your message on the chat. You can drop your question on the chat. So I will try to answer it at the time itself. Okay, so what is Internet of Things? Coming to the basic simple question. So IoT, Internet of Things. So Internet of Things is, I can say, a network of physical objects or things. So basically, we all are using internets. Currently, we are connected with the internet, right? So this is called Internet of Mobiles. So basically, the concept of IoT was introduced in 2007, and in that it was discussed that why not the things can communicate. Things have become smarter. They can do a lot of stuff for us, but what will happen if the things can communicate? They can take decisions on their own. So Internet of Things has introduced from there. Now these things can be anything. It could be any physical objects. It could be your clothes. It could be shoes. It could be your entire industry or a factory, right? It could be your wearables, anything, your home, anything can make it smarter with the help of Internet of Things. So what happens and what is there inside the Internet of Things? We have something called embedded systems. So embedded system means we have some sort of electronics in which all the different hardwares and softwares are there that can make your device smarter. Your device can share the information with the computer based world, right? And they have some sense of sensing the environment and also a sense of control, and we can control the devices from anywhere. So let me give you a simple example. We all are aware about home automation system. We have seen Alexa, Google Home, a lot of devices are over there. So what happened in that, you can, from your voice instruction, you can turn on your lights, your any devices which are connected in your home. So let's suppose you are traveling somewhere and you have a home, and at your home like you forgot to turn off your air conditioner, and now you are outside from your home, and it's not possible to go back, and you are on a vacation. So it will be a trouble for you because there will be so many situations. First will be the physical condition of the device can get damaged. Second is the electricity bill. That's a problem. Another, there can be some misleading or mishappening can happen because the device can be on for uh, I can say a large amount of time. So those are the some of the problems, right? What happened if we have such a system by which we can just open our mobile phones, and from there we can see the conditions of our device, whether it's on or off, or if they are on, so we can just turn off from there automatically. So this is what Internet of Things is in a basic sense. So now why we need IoT? What is the need of Internet of Things? So I'll give you with a simple example. It is a very hot and trending topic. You all have heard about this technology now or before, right? And it's keep on booming. Why it is so popular? What is there inside? So I'll give you with one simple example in which we'll take two case scenarios. Okay. The first scenario is where we have implementation of IoT. Okay. Here we have implementation of IoT, and the another scenario where we don't have IoT. Okay. So no IoT. So we are taking two situations right now. Now, the first one, okay, in the first situation where we have implemented IoT, Internet of Things technology, okay, and so let's suppose there is a elder person and he is living alone somewhere in his house. Suddenly, at the mid of night, he started getting a chest pain, right? And it could be a sign of a cardiac arrest. And he's living alone, so it's difficult for him to, take a call and call someone. But he has a smart wearable. He is wearing a watch that can sense his pulse, and continuously it is monitoring his condition, and it is also connected to a nearby hospital facility. So what happened at midnight, suddenly when this device was reading the values and it got some wrong values, that they, so devices automatically process the information that the values, these are wrongs and there must be a problem with the person. So what will happen? Let's suppose this is the person, okay, and the device has detected that there is some problem with this person. So immediately this device will send the information to the nearest hospital facility. So there will be an hospital, so it will send the message to the nearest hospital facility. Over there, a team of doctors will monitor the situation of the patient. At the same time, the device will send an information to the nearest ambulance service. So this ambulance service will get the location also of the patient without making any call because of an automated system. Now, ambulance can go to the patient place, and what will happen? The ambulance will come to the patient place. Meanwhile, what doctors will do? Doctors will continuously monitor the physical condition of the patient. They will prepare the bed, they will prepare all the medicines, and they make their staff ready. Meanwhile, at the same time, now the ambulance reached to the patient's destination, and they have picked the patient. Now they have started arriving to the doctor's place, and doctors are continuously monitoring the situation, and they have some sort of dashboard or control from where they can see the physical vitals of the patient. So as soon as the patient will arrive, that they will admit him and can do the necessary medication, and the life of patient can be saved, and all this process can be done in a very less time. So if it is like at around 5 kilometers, so we can roughly estimate it like it will take 10 to 15 minutes. And here the patient also, if he is unconscious also, still the ambulance can go to that place and they can pick up the patient. Now this was a situation when we were implemented the IoT. Now I'll take another part where same situation, but there was no implementation of IoT, there was no IoT at all. And now this time what happened? Same person was there, suddenly got a chest pain at mid of the night. And now what happened? He will be panicked first of all, because sudden pain, and he will be panicked. He will not be able to understand what is happening, and he will try to call someone, but there is no one around. And let's suppose after that, by any case, after 5 to 10 minutes after struggling, he is able to make some call, right? So he gave a call to 911 or any other emergency services, right? So he make the call, and now he is not in a right situation or the condition that he can inform everything. He can give the address, he can give all the necessary information, right? So that will take some time. At least we can take it like 5 to 10 minutes. In some cases, even the patient is not able to make a call, so that can lead to a lot of fatalities, right? So anyhow, he made the call. Now the call have been made, and the 911 services have taken the address, or maybe from the call location, they have traced the location of the patient, and they have sent ambulance to the patient place. Now the ambulance arrived to the patient place, they have picked up the patient, so it will take some time again. Now they will reach to the hospital. Okay, the ambulance has arrived, and then they will reach to the hospital. Now the doctors and the medical staffs are completely unaware with the physical vitals of the patient, right? So as soon as the patient will arrive to this place, now doctors will first of all monitor his physical vitals. They will check everything, and from there then they will arrange beds, they will arrange the medicines, and they will prepare the stuff. So that will take a lot of time. So this can take roughly, if we estimate, like 30 to 35 minutes, right? So now you can see two things. There is a life death scenario. If we have an implementation of IoT, we can save lives. This is just an example in the healthcare industry. Similarly, we can go to any industry. If you are not only in the healthcare sector, you can go to the environmental sector as well. There are most of the time we always listen that there is some casualty, there was some gas leakage, or there is some other physical environmental effects have been there because due to increase in pollution, people are getting lung cancers and everything. So if we have an automated system implemented over there, we can continuously monitor the situation, and accordingly we can take actions, right? So this is there. That's why we need IoT. And similarly, there are hundreds of application, we can say hundreds of needs are there. So we'll just focus on some of them. So first is the medical and healthcare system. Then we have environmental monitoring, home automation system. Everyone wants their home to be smart. They have some sort of home security system through which they can continuously monitor their home in case if they are not over there, right? And and they should avoid any unauthorized breach into their house, right? So then we have industrial management system. So great implementation, great advantages over there in the industrial management, so that we are going to study later on in the meeting. Then we have the transportation system. Again, you have a fleet, and in that transportation fleet, you have a different types of fleets in which you are having a cargo business or a delivery business, and you want to track all your trucks or cargoes. From there you can just continuously monitor them, see their exact location, and accordingly you can inform your customers, and it is beneficial for you and it will help you in saving a lot of cost. So that is also over there, right? And one good thing is that you can do the entire stuff from anywhere, any part of the world, because everything is connected through the internet. Okay. Okay, so let's go to some of the applications of IoT. Here we have an automated parking system. We can have an automated parking system where we don't need any security guards, or we don't need any staff to to take care of the entire parking slot. We can have some parking system in which directly when the car enters, and the person or the car, if the car is also autonomous, the car can get the information that okay, this particular section, so let's suppose we have a tower over here in tower B, on the first building or the first site, we have the second slot and the fourth slot empty. So the car itself get the information, or maybe the driver can get the information on some sort of app, and they can automatically go over there and park their vehicle. Accordingly, it will give some information to the other car drivers also who are going to park their vehicles. They can get the information that how many parkings are currently consumed and how many of them are available, right? So this is one of the application. Another one is our smart home management system. So smart home is the most popular one in IoT. So basically everyone wants to control their appliances remotely from their mobile phone or by giving some sort of voice instruction. Also, not only locally, they also want to do it globally. So if I'm sitting right now over here and I want to monitor my home from my office, so I can just open my app, I can see what is happening in my house, how many appliances are on, and what is the current environment condition around my home also. So these all things I can do it with the help of Internet of Things. Then we have a smart wearables, as I've already given you an example. So smart wearables help you in maintaining good physical health. And if you are like a fitness freak, so most of us are using Apple Watch, and there are other wearable devices that can monitor your pulse, that can give you the amount of calorie burn, right? So all the data, and that is too being recorded, and accordingly we are getting the right values, and accordingly we can work. At the same time, if we have this system connected to some sort of healthcare system, so in case if some sort of mishappening is there, so the system can automatically inform the concerned authorities, and necessary actions can be taken. Similarly, remote patient monitoring system. So I can say it is a boon in the healthcare sector if we have this thing. So doctors can continuously monitor various patients and can study their vitals. Accordingly, it will help doctors as well as for the patient also. They can give the right prescription, and they can do the right medication for them. So again, these are all the great applications of IoT. Other than this, there can be hundreds of other application in the I can say in the defense sector, especially for the forces, for the armies. They can track their enemies. If anyone is intruding the border, they can track them. They can also track any types of anti-dynamites or anything is over there on the land just by doing physical surveys. They can have autonomous drones that can be controlled remotely. They can launch it and they can be controlled remotely, right? So multiple applications are there, and you take any industry, IoT has its application. Your smart city application, in your smart city, you have automatic street lighting system. You can control all the street lights in the entire city as well. They will be autonomous, as well as you can have a manual control on the system. And then smart transportation system will be there. You have a smart logistics system, and in the smart transportation system, you have automatic street lighting, and your traffic light, automatic street traffic lights are there. So accordingly, like if the traffic is more in one of the lane, so it can change the signals accordingly, right? So that is also there. You take any industry, there is an application of IoT. Now let's go a little bit deeper in one of the application of weather monitoring. Okay, so what will happen in the application of weather monitoring if we have like IoT? And so this is one of our home, and in our home, so let's check. The first one is that if we have a smart weather monitoring system. So what is a smart weather monitoring system in this?
Okay.
Okay, yeah, never mind. So if we have a smart weather monitoring system, right? So what is this smart weather monitoring system? Basically, you create your own weather monitoring station at your home. You use some sensors, and that sensors can detect the temperature and humidity condition near your house, and can give you some information that the current temperature is 25 and the humidity is 50%. And why we need this weather monitoring system? Because the temperature information or the weather information we receive from the websites or in the news, they are not 100% accurate, because that is for a complete region. They have installed this weather monitoring station at some one place or two place in the city. But if you have your own weather monitoring station, there is a huge advantage. You can know the exact temperature condition in your area, right? So now if we have this smart weather monitoring system, so we can maintain an ideal room temperature condition. So if we can know the outside temperature, we can accordingly maintain the room temperature conditions from our room inside it. So that can save us a lot of cost, and like the system will be also autonomous. You need not to control it manually. Then we can protect valuables from environmental effects. So if we have like some valuable goods, and if we monitor that in the humidity level rises, so automatically we can turn off the curtains and the windows, right? We can avoid mishaps due to water leakage. So if there is any water leakage in the house, we can have the smart system that can detect any type of water leakage and can give us the message. So accordingly we can repair that. Then efficient cooling and heating of the indoors, right? Quality of indoor air, we can also measure the amount of toxicity in the atmosphere. Accordingly we can turn on our air purifier and turn off our air purifier. Then best condition for gardening, if we are getting the information of the weather condition as well as the moisture data, right, from the soil, so we can accordingly we can make the automatic watering system or smart irrigation system turn on. Then best monitor pool temperature and quality. So that's it. Like if we are aware with the outside temperature, accordingly we can increase or decrease the temperature of our pool. All right. Okay. Now coming to the fundamental blocks. So we are not going to dive much technical right now, but still I'll give you some idea about IoT. What are the main components of IoT? This will be a fundamental block. If you are going to design any system, or if you are going to implement any IoT system in your existing model, this will be the fundamental block. So basically in IoT, we have four main components. Okay. We have four main components. The first one is the things. Things could be anything. It could be anything. You take anything and you want to make it smart, take the thing, right? This could be a sensor also. This could be an end device also sometimes, you can see. So let's suppose if we have a shoe, okay? And this shoe, we want to make a smart, we want to make an IoT system with the shoe, that this shoe can track my location, as also and also it can count the number of steps I'm taking, right? So I'll take just a normal shoe, then I'll require some sort of mechanism, right? Some sort of softwares, because right now we are using internet, we are communicating via Zoom meeting. So there is a device, right? You might be logging via mobile phone or a tablet or maybe a laptop or a computer, right? So these are some electronic device that has some sort of hardware, and there is some software which is running on, and we are connected via internet, right? So we need some hardware, right? We need some embedded system. So embedded system means a system in which multiple things are embedded together in one thing. So it has a hardware, then it will have some software in it, operating system, right? A lot of things are there to make it smart, make it connected to the internet, that can sense and also send the information. So this is, we require an embedded system. So this one is number one. This is your number two. And then we require a connectivity, right? We want to send information to the cloud, we want to store this information, right? So if we are like sending the data, we want to send this data to some place so that we can monitor it from anywhere. So we need to send this data to a cloud, right? To some remote facility, to some remote server where it can store, it can get processed. Because if this is the shoe and this is counting the steps, right? And also we have to monitor the location of our shoe, that where this person is moving, if if he is wearing the smart shoe. So the data which we will receive will not be in a proper readable manner. We want to process that information. We want to show that information in some form of a graphs, some sort of charts, right? We want to show this information like this so that it is easy to read and understand, and then we can take whatever necessary actions we want, right? So we want to send this data, we want some connectivity. So this connectivity is done with the help of internet. So you need to provide internet. So that's the basic fundamental requirement of IoT. You need an internet. Without internet, you cannot send the data, right? So you need internet, and through internet, you can send your data, store it in any form of a cloud. You can take any private cloud, public cloud, right? So not going much deeper, private cloud is that you own it. Public clouds are your AWS, Microsoft Azure, IBM, Google Clouds. A lot of options are available over the internet. You can send the information over there, and from there you have some sort of dashboard and application which you can develop. Otherwise you can use some ready-made application, and then you have end user. Okay, end user or the remote user, the user who is going to monitor this application, who is going to work on this particular thing. So this remote user has some sort of dashboard. So we have something called UI, that is a user interface. Okay, so we have a user interface, that is our fourth component of Internet of Things. From here, our user will monitor everything. He will monitor all the different types of data, right? Okay, so let's move further. If you have any doubt, feel free to drop your question on the chat. I'll be very happy to answer that. Okay, now to set up Internet of Things, what we need? Okay, to set up an Internet of Things, we require connectivity. As I told about you, the four main components, that will be the fundamental blocks. Now, if you want to set up an Internet of Things in any thing, in any device, you can make even a smart cloth that can detect, when to wash them, right? When they are dirty, that will send you the message that, you need to wash your clothes. So that will be a smart cloth. So if you want to make your clothes smart, you need to have some sort of hardware that can have some processing power, that can sense something, right? It can sense something, it can process it, and then it can send the information on your mobile phone, right? So for that, if you want to set up these things, so we require a connectivity, some sort of CPU architecture, because uh, we have like a need of a processing, because if we are getting data from somewhere, right? If we are getting some input, we need some sensor, right? If we want to make a smart cloth, so it will detect something, right? It will detect the condition of the cloth, right? So we need some sensor. Okay, and then this sensor will generate data, right? This will sense something, and it will generate data. Sensor could be a device. It's a physical device which can sense the physical environment and convert it into electrical signals. right? So it is sensing data. If it is a temperature sensor also, let's take an example of a weather monitoring system in which we have a temperature sensor. Temperature sensor, it senses the temperature and humidity data, okay? And now this temperature and humidity data, we got the data. Now we need to process this data. So this data will be sent to a microcontroller, okay, or a CPU in simple word, right? This microcontroller has all the processing system. It has all the softwares, everything mentioned is over here, right? So this information will be processed over here, then it will send it for the output. So output will be in the form of connectivity. It will be it may be sending data via Wi-Fi, it may be sending data via LAN also, right? So connectivity to the internet, right? So this is what we need. And inside CPU you have an operating system. You require some sort of protocols. Currently we are communicating, right? So if we are accessing our internet, so we have seen HTTP, right? And we all are aware about hypertext transfer protocol, which is basically used to access the internet. There are other protocols like FTP, file transfer protocol. We have mail protocols, right? Similarly, for IoT also, you want to send information, you need to have some protocols. So protocols are some basic standards or set of rules to send information or to exchange information and data, right? So we have some communication protocols in IoT. Then we need a data storage and data analysis. So continuously our devices are sensing the temperature and humidity data. If we are monitoring them in the real time, that's okay. But we are not going to sit 24/7 and monitor the condition. We want to store this information and then we can analyze if we want to take any decision on that part. So the data which is being generated by these sensors, let's suppose it is sending data at every 5 seconds. Okay, every 5 seconds we are getting temperature and humidity value. We need to store this data somewhere, right? So we'll store this data in some sort of a data storage. It could be a cloud. So here we are storing the data. Now the data is stored. As I told you, the data is not always in the readable manner. We want to see it in some sort of a graph, chart, or some manner so that we can visualize it very well, right? So we need to do some data analytics on that, right? Did some data analytics on that. So that things, those softwares are also there on the cloud or the server. And then you have an end application. Okay. Moving further. Now coming to what is IIoT and Industry 4.0. This is very interesting topic. I think most of you must be aware of IoT, Internet of Things. One time or two times or maybe multiple times you have heard this word. But Industrial Internet of Things and Industry 4.0. This is very hot thing right now. Now, what is this Industrial Internet of Things and what is the Internet of Things I have explained and what is Industry 4.0? So let's understand. So Industry 4.0 is basically your fourth industrial revolution, right? So we now, I think it clicked something if you're not aware. So industrial revolution happened, the first industrial revolution, we all are aware. After that, the today modern era, which we all are seeing today, we are the devices and everything which we are getting, that is because of the industrial revolution. The first industrial revolution was around some 1784 when we introduced the first mechanical system in which we were having the mechanical machine which were operated by humans and mans, right? So they used to operate these machines physically. There was no electrical system or an autonomous system. You need physical person, you need to do physical activities, then you can produce something. After that, your second industrial revolution started around 1870. And in that, after the introduction of electricity, right, the second industrial revolution started in which we were using the automation. We introduced these motors, we used electricity in production, so that cut down a lot of cost, and also it helps in saving a lot of labor cost and saving the life of the laborers over there, right? So, and also it resulted in mass production because the system was running on electricity, so you don't require a physical person. And for humans the capability is limited, right? Sorry, in limited, like they can work either for 8 hours or 12 hours maximum. And if we are using a machine which is running on electricity, we can run it 24/7. Then after that, the third industrial revolution started. So what happened in third industrial revolution? Second industrial revolution, we introduced electricity, but still we need people to operate them. They need to stand near the devices, they need to stand near the machine, they need to operate them, they need to turn it on, turn it off, monitor the physical goods and products. So when the third industrial revolution started was around 1970s, right? So in the third industrial revolution, your use of electronic uh, devices have started, electronic and IT system. Now we have started manufacturing the small chips, and we started manufacturing the PLCs, programmable logical controllers, and a SCADA system in which we can now have controller boards. You need not to do physical turning on and turning off the system. You have a proper dedicated screen to monitor the manufacturing unit, to see the production, and that system was more precise, more accurate because of using the electronics, and also we can save a lot of cost over there, and accuracy was high compared to the second industrial revolution, because there is a human and there is a chance of human error. But in the third industrial revolution, we have electronics, and the system became more advanced and more precise. So the production and I can say the cost, everything increased in the third industrial revolution. After that, the fourth industrial revolution started. It's around 2010 and 11, I can say. And in the 2010 and 11, what new system came? In industrial revolution, the fourth industrial revolution, also we call it industry 4.0, and sometimes we call it only 4.0. So what happened in this one? We have introduced something called cyber physical system. Now, what is this cyber physical system? We have a physical system, we have physical machines, we have physical looms, and let's suppose we have physical looms, and we want to make this physical machine a smart machine. We have given a brain to this machine now, right? We have given a brain to this machine. Now this machine can operate on its own. It can communicate with other machines in the entire industry. So let's suppose in our industry we have like 25 machines. Now all these machines are having their own brains. They can communicate with all the nearby machines. So if the machine one is on, which is taking a raw material, and and after processing the raw material, it is sending it to the second machine. So rest of the machines will be off for the time being. They will not operate. So as soon as the processing will start from the first machine will turn on. After that, when the processing will start, the second machine will get a signal that will turn on again, and then they will do the processing, and rest it will keep going on until the final product, right? So this thing has introduced in the fourth industrial revolution, the cyber physical system. I can say a combination of a physical system with a cyber, means it's a computer. You can have a brain, you can have a processing and computational power in the machine. Also, at the same time, you can control them from anywhere. No human involvement or zero human involvement is there in this fourth industrial revolution. In the third industrial revolution, robots were introduced in the third industrial revolution only, but there were so many casualties used to happen, because when robots and humans were working together, there was no proper I can say no proper coordination was there, right? And that leads to sometimes casualties. So after that, in the fourth industrial revolution, what started, that no human involvement is needed, or very less human involvement is needed. So if we were needing like a staff of 500 in the third industrial revolution for one industry, now you can operate with a staff of 5 people in the fourth industrial revolution, and it is highly precise and saves a lot of power, and I can say a cost for the company, and increased productivity at least 5 times, right? So this is what happened in the fourth industrial revolution. Entire system was autonomous, and the machines can predict that when they want to get maintained. So you need not to do a scheduled maintenance. The machines will predict from their side that they require maintenance before a week. So you'll be getting the details accordingly. You can send engineers, and they can operate on that particular machine. Rest of the entire system will be working. So here, if we see the graph, as we are proceeding in time, the degree of complexity is also increasing, right? So the fourth industrial revolution is very complex. So it introduced the topic of called IIoT, that is Industrial Internet of Things. Now, what is this IIoT? Before jumping to Industry 4.0, let's understand what is IIoT. So in IIoT, that is also known as Industrial Internet of Things. This is same. The main components are also same. The fundamental or the basic blocks are same. The basic working is same. The difference between the IoT and IIoT is this much, that in industrial Internet of Things, you have the machines or the devices which are basically used in industries. So some protocols which are related to industries, so that are used in industrial Internet of Things. IoT is moreover related to your commercial use or the daily uses, things like your smart home, right? Your smart home or the healthcare sectors. So this is your just a simple IoT, and industrial IoT is basically related to your industry 4.0. So the automation which is needed inside an industry. So that is what being done with this industrial Internet of Things. So that is just the basic difference. We also call it as IoT 4.2 sometimes. Okay. Now in industry 4.0, what happened? In industry 4.0, we got products, we got machines which are smart, which are aware. They are smart product, they are aware with the physical surroundings, and they can monitor the condition of the physical surrounding as well as of the machine. So they are aware, they are intelligent, they can process that information, they can take decisions, and also they have a system of self learning. They can learn from its mistake, they can learn from the errors, and accordingly they can take a system. They have a closed loop system, right? So some problem or some situation happen, they can learn that situation, and next time when the new product comes, so they will not repeat that mistakes, right? So they are intelligent machines, they are highly responsive. Okay. So and the products are, I can say, well equipped, and they have some sort of processing power. So if you give any input, if you give any commands, right, they can respond you immediately, they can send everything. Like if I have a smart factory, I want to know the situation of all of my machine, I will just send some command, some message from here, and the machines will respond back that currently they are operating at this much frequency, they are processing this much amount of product, and this is the current situation of the machine, right? So these all information I can get. So they are highly responsive. Then they all are connected. The main thing, they all are connected. So all the machines which we are using inside the industry, if there are 100 machines, 500 machines, or 5,000 machines, they all are smart, they all are connected to each other, as well as they are connected to a outside server or a cloud. From there you can continuously monitor them, and these machine can also coordinate between them. They are using M2M communication. This is very popular communication in industry. So machine to machine communication is like, there is a communication between different machines. So if you have 5 different machines, so they all are connected via this M2M protocols. There are different protocols available under the machine to machine. They can exchange information, they can communicate with each other in that process. Okay. So let's move ahead. So in industry 4.0, let's understand about some of the technologies. So what are the technologies which we have in industry 4.0? So some of which I'll say, the first one is your Internet of Things, IoT, right? So that we also called as IIoT. Then you have big data analytics, because in industry you have so many machines, so many devices, you are getting so much data which is being generated from these devices continuously. Production, their efficiency, the power consumption, their physical condition, right? So much amount of data is generated. Their data is a very huge amount, which is difficult to process and analyze. So we have something called big data analytics which we use for that. Then we are storing this data somewhere, so we need a cloud computing technology, so that we can get all the data on some cloud and can access from anywhere. So if I own an industry and it's a smart industry, I implemented industry 4.0 in that. So let's suppose I'm sitting in India and I have an industry in US, and over there I want to monitor everything. So because of cloud computing, I can see each and everything, and also I can control it at the same time. Then you have something called simulation and prototype. So what good thing is being implemented in industry 4.0 is that you have an option of creating a prototype and a simulation of the entire smart factory or industry. You need not to invest money. You need not to invest money directly purchasing the equipment and starting it, and later on you got to know, oh, there is a problem, or this machine is not compatible, or this system which I have purchased is not compatible with this. So in Industry 4.0, you have an option of creating simulations and prototypes, which can create a shadow of the devices. You can create a shadow industry just on a software, and you can apply, you can check various, I can say, iteration on the machine by changing different values just with the help of softwares, and then from there you can get the specified data and you get the right information before actually starting a new industry or jumping into a new sector, right? So that is an option. Then you have something called 3D printing, which is very popular again. So 3D printing technology helps you to print the objects, prints the components directly like we are using our 2D printer. So 3D printers are of different types. You might have seen some of the 3D printers in which you can print some plastic objects. There are 3D printers which can actually print metallic things. Even the 3D printers are there which can print the body parts or organs, and they are being used, right? So that is their 3D printing technology, and it's very popular in industry. Then augmented reality, virtual reality. Basically, augmented reality, you can just use AR and VR from there, like not only directly going inside the industry, just by sitting in one room, you can just go and get a virtual tour of the industry and can see each and everything, right? So AR and VR again very popular in this sense. Then robotic system, for of course, because the system need to be autonomous. You need to have, if you are replacing humans, you need to have robots that can take actions. That so robots are basically machines that performs actions, different actions depending on the inputs. So robots are there. Robots, like basically we use robotic arms moreover in the production units. So robotic arms are similar to human arms, but they can do a lot of other stuff. They are highly precise. They can lift heavy loads, and they can give all the different information. They have more degree of freedom in the rotation. So robotic systems are there. So these are some of the technologies in Industry 4.0. Then this technology has some process integration. So what is this process integration? We have something called shop floor equipment integration. So what is the shop floor equipment integration? This is the terminology we use in Industry 4.0. Shop floor is basically called the main industry where you keep the machines, right? So that is called shop floor equipment integration, right? So we do this integration with our these technologies. So the main shop floor which is there in our industry, we do the integration with that. And also we have human machine collaboration, because everything is automated, all machines are automated, they can do everything, but still we need something. If I'm the owner of that industry, so I need to see what is happening inside that. So there is some sort of human machine collaboration. We have some sort of physical or a monitoring system from where we can monitor each and everything. Then what are the sustainable outcomes we can get? So sustainable outcomes are like, the system will be highly economic, then process automation, and there will be increased safety in that. And also there is an environmental protection, because for everything we have implemented the sensor. So if there is any problem, or if there is some situation of fire or a gas leakage or something, we can immediately get that information. Necessary actions can be taken, right? We can turn off the entire grip. Got it? Okay. Now, under this, we have one more thing, or one more layer, that is called cyber security layer. Because we are using internet, and every day we get the news that the system is getting hacked or this information is hijacked. So we have the cyber security layer, and cyber security layer help us in solving these problems, right? Then we have 6 principle in IoT, internet industry 4.0, sorry. Interoperability means devices can like operate, different devices can operate with each other. So there is no specific set it standard that you need to purchase Apple only, that all devices should be from Apple company. There should be no Samsung or any other company. They are not compatible. So that's not a problem. Interoperability, you can take any devices from any company. There's a virtualization. We have real-time capabilities, decentralization, modularity. So modularity, let me explain. Modularity means if you have an old system, you want to replace some part from that, you want to implement a new part. Let's suppose after 5 years, because the machines is so costly, I can't replace the main machine, but I can replace the technology in that. So I can replace some of the parts in that. So that thing is also over there. Then we have service orientation industry 4.0. So as we are running out of time, so I'll be just jumping from here. Okay. Now we have a industry 4.0 smart factory. So in the smart factory, customer places an order. So if you have like 3 different cutting station, if any of the station is busy, right? So the signal will go to all of them. If any station is free, so that station will get the message and they can start the cutting, right? So this is how your smart factory works. Right. Similarly, there's an example given for us industry 4.0 supply chain also. So if you want to manufacture or build some product, so you can implement industry 4.0 and remotely sitting from one place. If you have an international business also, if you have 10 different factories in different countries also, they can be automated, right? So with the help of industry 4.0, it is possible. Now let's go to current industry trends. Okay, so what are the current industry trends in IoT? So you can see this graph. So we have this sky blue over here is showing you in 2015 how much amount of money we were spending in IoT, and then 2020 you can see how much amount we are currently investing or spending in IoT. So this is information from Statistica, and this expenditure is given in the billions of dollars, and you can see different industries over here. So over here you can see a lot of amount is now being spent on IoT. Okay, moving ahead, here we can see the amount of devices. So as per a study by Cisco, so they have like expected that around 50 billion devices will be connected to IoT in 2020, right? 50 billion devices. That means around 7 devices per individual. Now here we can see new statistics now that by 2025 we will be going to have more than 75 billion connected devices. So much amount of data is there, so much amount of job opportunities will be there. Here you can see some biggest IoT acquisition because this technology is very hot and it's going to be, I can say, for a long time in future. So here you can see a lot of biggest IoT acquisition. The big one is by SoftBank for ARM. ARM basically a company manufactured the microcontrollers, so that is for $32 billion. Then a Nest by Google. It's a home automation company acquired by Google. So a lot of them are given over here. So that's a very hot industry, hot technology, you can say. Then here you can see use cases with most investment. So manufacturing operation, management, home and freight. So freight monitoring, home smart management, and then manufacturing option. These are related to industry. So from this only, there are like various industry, but from this only I can give you an idea that is $200 billion in this much use cases, right? So IIoT is very hot. So if you are having a business, you're a business owner, you need to implement this. If not, you will be on the backside. Your competitor will go ahead of you. Now, it was expected that IoT will generate or will be an industry of around $1.3 trillion. Okay, $1.3 trillion industry. But COVID has also affected this. Even COVID affected the IoT industry also. So now it is estimated that it will be around $1 trillion or $906 billion by 2025. Okay, so we got around $200 billion of loss, right, because of COVID. Okay, so moving ahead. Now, what is the benefits of IoT to the business? So 83% of organizations who have implemented IoT already, so they have shown that they have improved their efficiency, right, because of implementation of IoT. And out of 83%, 36% of the companies have got a new business direction in their businesses. So if you are an existing business owner of something, if you have implemented IoT, new ways or new verticals will get open because of the implementation of IoT, right? So there are huge benefits, huge advantages are there. Now, what is the best time to adapt to Industry 4.0? I'll say this is, or the current time is the best time, because we can see the growth, we can see the number of devices going to increase, and $1 trillion industry is waiting for us. So if you are a business owner, if you are running something, so it's the best time to switch to Industry 4.0 or IoT, right? So that your system or your will become smart. You can increase your revenue, you can get new ways, and you can be ahead of your competitor. So thank you so much, guys. If you have any questions, you can ask.
Thank you, Shashank. This was a great presentation. Let me clap. Yeah, I just started the clap emoji. Are there any questions? Feel free to raise your hand and I can unmute you. I think there was a question by Rowley Max. He said, what is edge in the IoT context?
Okay, so edge is basically, uh, so when you have a device, when you have an IoT device, so we have four main components. The first one is the thing, and then you have embedded system, then you have internet, and after that you have data processing. Edge means not having a cloud. Okay, you can process the information in the device itself. So if I'm having a smart home automation system or a smart security system, so at the edge only, means near to device, edge means near to the device, there only I will do all the necessary processing and I will take action, and only required information I will send it to the cloud. Rest of the information I will keep it over there. So in case if we are not having internet connectivity, our system will still be functional. So it's an advantage. So previously it was a drawback in IoT. Now using the edge computing concept, we have remove this problem, and now it's an advantage. Yes. Okay, if traditional
Thank you,
manufacturer is
Shashank. There's
considering.
another question. If a traditional manufacturer is considering transition to IoT, who would they seek help from in order to take the initiative?
Okay, so you can reach out to experts, you can reach out to IoT experts in the industry or IoT consultants. And if you are having your existing system and you want to make it a industry 4.0 compatible, you can reach out to an expert. They will take the information about your existing industry and how you have implemented the stuff, and they can give you the information how you can implement the industry 4.0 in that.
And also just to note here that if you care about implementing IoT in your business, this is what the full event is for, right? So let me type in, oops, sorry, wrong. I wanted to copy and paste this link, ignore the previous message. Here is a link to the full event. And if you send me an email at this email address, I'm happy to also give you a very nice discount if you send me an email within the next couple of days. And once again, for those who want to join the full event, don't take the date and the time at face value. The actual date will be determined by the participants. So we're using Eventbrite as a ticketing system, but the actual date is going to be held, the event will be held on a date and time that's convenient for everyone. There's someone, Rowley again is asking a question, yes, how complicated it is to apply AI to data then generate business benefits. That's a great question, because this is some of the things that we cover in our workshops, including the full IoT workshop and also some other programs of the Tesseract Academy, such as data science for decision makers, also covered in the book, which is available for free if someone joins our newsletter. But maybe Shashank would like to give your insight on that topic as well.
Okay, so if you want to implement AI, so I'll say it is complicated for the person who are just starting up in the implementation of AI in the IoT, and you can generate the business profit. Basically, when you are generating data, because IoT, there are 50 billions of devices in 2020 and 75 billion of devices will be there in 2025. So you can see trillions of messages and data will be generated per second. That will be there in the cloud. Now, when you have so much amount of data, you are going to process that data. So that will be done with the help of data processing. You got the data, after processing the data, you will be implementing it, because how you generate the profit, you have so much data, that data means benefit, profit. Now you want to generate profit for your business. You got so much data for the customer, they're happy, unhappy, how many times they are ordering that particular product. So if I'm taking example of an e-commerce sector, now that data when you are implementing the AI in that, you will be developing some models, some machine learning models, right? So these machine learning models will help you in prediction. IoT is not only just monitoring and sensing. IoT is also about the prediction. You can predict the things before. You can even, like how we have the current prediction system for our temperature or rain. Same way in IoT, if you have like, implemented this AI is basically your artificial intelligence, and that will be done with the help of machine learning models that we will be developing over the cloud, right? So when we'll develop these models are going to help us in prediction, and they will predict. Now today we are going to get 500 orders, so accordingly our machines will be prepared. Or if we have like 50 machines, so out of which 25 machines will be ready at the time, right? We can like, prepare for everything, and that will be autonomous. So this is going to generate huge profits for the business because you have a prediction. So accordingly you can prepare your raw materials and everything. Yes.
Yeah, so I think that's great input. And also, if anyone else is interested on better understanding how data science and AI can be implemented, here are also some of the free tools and frameworks that we have on our website, which can help you understand how to do this in the best way. Like, for example, the data strategy canvas. These are some tools that also in our workshops we're covering. So if anyone is interested to learn more, please make sure to send us an email, send me an email directly. I will be more than happy to help you out. Any other thoughts before we conclude? Okay, if there are no other questions, then applause for Sasan. Thank you for your insights today. And we hope to see all of you in the full workshop. Thank you.
Thank you so much, everyone. Have a great day.
Thank you. Bye-bye. Take care.